Again, for lipids at room temperature, the saturated fatty acids having carbon 12 to carbon 24, 12 carbons, so 24 carbons, they have a waxy consistency, whereas the unsaturated fatty acids of this are oily liquids. So you notice again for your samples of oils in yung balay, whether it comes from animal fats or it comes from um, vegetable oils, no? You notice na yung mga oil na matulog. Mga matulog na oils, usually they have saturated fatty acids in them. Of course, the oils that we're using at home are mixtures of fatty acids, saturated fatty acids, and unsaturated fatty acids. So depending on the percent of, remember the fatty acids that we have mentioned earlier from carbon 12 to 24, whether they are saturated or unsaturated, they're always on a mixture, no? Sa kanilang mga fatty acids. So, depende kung sa'yo pinakadaghan. Kung daghan ang saturated fatty acids, i-expect sa inyong mga oils na matulog, no? Pag especially kung now, ako yung mga kinds of oils na mas ipaugnaw, hindi po siya matulog, hindi niya siya sa rep. And then, mga peanuts and peanut butters, no? Dali na po matulog, dali na magkahi, no? But naiuban nga sa kuan, even if nakabutang sa ref, liquid gihapon, liquid yan. So again, it depends on the kind of fatty acids that's being present on your food sample. So the difference in the melting points that the saturated fatty acids have a higher melting point than unsaturated is due to the packing of these fatty molecules. Again, in the saturated fatty acids, highly packed, no? It's very organized as compared to here, in such a way that we need a greater force or a greater energy to break this interaction here and therefore increase our melting point. Next, stop. Okay, we have already the examples in the table, and on the let's see, our source of fatty acids actually comes from the triglyceraldehydes. So triglyceraldehydes are animal fats and plant oils. These are our source of our fatty acids. They are triesters of glycerol and long-chain carboxylic acids called fatty acids. So here is the structure of our triglyceraldehyde. You notice here you have your CH2 CH here. And here you have acyl bond OO, and then you have this chains of the hydrophobic end of your fatty acids here. Here you have your CH, and you have your acyl bond O, and then chains of hydrocarbon here, depending on the number of carbons. And here another CHO, acyl bond O. This is your carboxylic end, and then you have your hydrophobic end here. So this triglyceride comes from the glycerol. It's actually composed of a glycerol and the long chain fatty acids. So interaction between or reactions between your carboxylic acid and your glycerol actually would lead us to this ester. This is actually an ester here. And breaking of this, hydrolysis of this actually obtain our glycerol and our fatty acids na katong mga inani. Hindi pang mention na to earlier. Okay, so what you can see in the triglyceraldehyde is kaning glycerol na part kaning CH2O, CHOH, and CHOH. When it interacts, when there is a reaction with our carboxylic acid, we actually obtain an ester. So you have acyl bond OO, acyl bond OO, acyl bond OO with an R here, with an R of course. This is actually an ester. So we call this one as triesters of the alcohol and the carboxylic acid, the glycerol. This is an alcohol and the carboxylic acid as carboxylic acids from the fatty acids made up your triglyceraldehyde. If we do hydrolysis of this, we actually obtain our glycerol and the fatty acids we have already mentioned. So esters are made up of an alcohol part and an acid part. That's how we do the synthesis of esters. As the name indicates, the alcohol of triglycerides always is glycerol. So the triglyceride is derived from the glycerol. You have the glycerol here, and tri, which means there are 3 carboxylic acids being formed actually in the process. So here you notice that on the side chain of this glyceride, you have the acyl bond on. There are 12, 1 plus 3, 14 rather plus 1, that's 15 plus 1, that's 16. So there's straight chain here, you have 16, 0. Remember on the naming, 16 carbons with no double bond. This comes from the palmitic acid. Because we don't have the acyl bond OOH, we call this one as palmitate. Salt of the palmitic acid, this end here is acyl bond O minus. This one's just called palmitate, 16 carbons with 0 double bond. Here you have carbon 1, 7 plus 1, 8, 9, 10, plus 7, 17 plus 1, 18. Okay, so 18 carbons and 1 double bond. Okay, so that comes from oleic acid, or the carboxylate of that is minus the hydrogen, the acyl bond O minus lang. You have the oleate. So this is the oleate, 8 and 1. Here you have your 16 plus 1, 17 plus 1, 18 carbons and 0 double bond. You have your stearate here, or from the fatty acid, stearic acid, 18, 0. Okay, so again, what's the difference when we end with 8, 8, 8, no? The difference is, you don't have the hydrogen. For example, carboxylic. You have your acetic acid, no? When it dissociates to form the negatively charged acyl bond O minus lang, you have the acetate, okay? And like, for example, your palmitic minus the hydrogen, you have the palmitate, or your stearic acid minus the hydrogen, acyl bond OOH, kani. No, minus the hydrogen, wala na butangi. This one is connected lang to your glycerol, no? This is how we name our fatty acids, no? We don't end with ic acid, but we end with, we don't end with palmitic acid. This is with hydrogen here, but we end with palmitate. We end with stearate minus the hydrogen. Our name would be stearate. Minus the hydrogen, you have the oleate. Minus the hydrogen, you have the linoleate. Okay, and so on, arachidonate. That's how we name our kaning anak ko. Ito maglibog na nata diri sa atong structure, sa atong glyceraldehyde. Kasi maglibog. Okay, so I hope that's very clear to you. So in the structure of the triglyceraldehyde, we have how many minutes left? It's already 1:31. Okay, let me end with this slide. On the structure of our triglyceraldehydes, you have, again, once you have get your sample of oils from your plant materials, no? Our plant sources and fats will have dili siya pure nga fatty acids. Dili siya pure nga, for example, palmitic acid lang or stearic acid lang, oleate lang. What we get from plant oils and animal fats actually are triglyceraldehydes. And from there is where we can get our palmitic acid, can get our stearic acid from there once you hydrolyze this one. That's how we get our fatty acids. So from plant sources again and animal sources, no, the triglyceride is what we obtain. Okay. So in contrast to the alcohol part, the acid component of the triglyceraldehyde may be any number of fatty acids. It can be a mixture. In the sample, for example, you have your, let me see, we have an example of a peanut. So peanut, let's say, peanuts na lang, no? You can have oils from your peanuts. It can be a mixture of oleic, stearic, palmitic acid once you have your triglyceride and a hydrolyzed natin na, you can have your source of oleate, stearic, or palmitic, or even, for example, coconut, no? Maghimo mo virgin coconut oil. It's always a mixture. What you obtain are triglyceride, and you do hydrolysis, so that can always have your tatong pure form na gid nga palmitic and stearic. But normally in nature, it's always a mixture of your fatty acids, and the mixture of fatty acids are contained na siya sa triglyceride structure. So fatty acids have certain things in common. Fatty acids are practically all unbranched carboxylic acids. So like branching mahitabo, the range 10 to 20 carbons or up to 24, no? They contain an even number of carbons. You notice even siya. And apart from the COH group, the carboxylic group, they have no other functional groups except that some have double bonds. So another exemption is katong atong icosanoids, no? Ang icosanoids nato that they have a ring. And you have an OH. Apart from that, there is no other functional groups present except katong sidopan OH lang. In most fatty acids that have double bonds, of course, you've learned that they have the cis isomers that predominates balik-balik. Okay? So, in triglycerides, they have three hydroxyl groups of glycerol in the structure. Katong glycerol sa tong structure, no? And our triglycerides can be mono or diglycerides, are not infrequent. Usually, we have the triglycerides katong three, the glycerol na tulo ka OH is substituted with palmitate our fatty acids, no? And sometimes, actually, it's not common or not infrequent. It can also have monoglycerides or diglycerides. Okay, so mono to, and we will look at later on how the glycerides are actually being obtained. I have already mentioned this earlier. This is our triglyceride here. You have your CH2, CH here, and you have this fatty acid part here, the salt of the fatty acid here you have in here. Okay, so bond O, this is the ester. This is a mixture of stearate, linoyl, and palmitate you have here. And to obtain that one, for this glyceride to be made, no, in the biological systems, it's actually a reaction between glycerol and fatty acids. I have mentioned that one, wherein we can get our ester. Okay, so first one is you get our monoglycerol. If one of the OH just react with carboxylic acid, this is from organic chemistry. The first reaction is the formation of your one ester, sidoban OH, it's an ester. From the monoglycerol, then you can have the second carbon to be estylated. You form another ester here, sidoban OR, and then you have, this is a diglyceride. You have two diacyl, you have two carbons being estylated, or you have the esters here of your fatty acids. And then you have here another reaction with your carboxylic acid. We have the triacyl glycerol. And this is just here in the product of the reaction, of course, you have water as one of your product. And we term our sidoban O as our acyl here. Sidoban O, this is our acyl. Okay, and TAG. Okay, so I think that's all, and we will continue with our lesson. Continue with glycerides, the fats and all other properties of this. Balik-balik siya, and later we'll have our examples that akong giingon on the kinds of animal fats and vegetable oils, and what is the percent of the different fatty acids for some food samples. Okay, so that ends our discussion for today, and I think we'll have our meeting after next week. You will have your next week. You will have your midterm break, right? Tama ba ko?
Yes, ma'am.
So, tama
Yes, ma'am.
sa 7. And then pagka 9, mabutar ba mo?
Yes, ma'am.
Yes, ma'am.
Vote mo, so of course holiday. Yeah, pagka 10, no, it's Tuesday. Tuesday ba ta? Yeah, Tuesday and Friday. So we'll have our discussion again on Tuesday, May 10. And so for now, enjoy your vacation for your midterm break, and hopefully you've learned something from the biochemistry course. And good luck sa inyo. So that ends our session. I hope that you didn't forget to log into your LMS and indicate your attendance. If you have questions, do you have questions? You have questions? Wala na question? Kung wala na may question, what about your laboratory? How did it go? For your laboratory, no, for those who would like to do laboratory, actual lab, and those who are able, no, would resume that one on May. Okay, langanin sa April, no. Okay, so if you have no more question, maura to, and see you next meeting. Apa may question? Hello, dili na. I don't know, ano, dili ko dili ko ka-search ng CDL1 ng 46 ba?
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Bye.
Thank you.
Bye. Good luck, Philippines, sa inyong butuhan.
Thank you, ma'am.
Laban lini, ma'am.
Lahi tag kampo.